Hello student. In this session, we start new article from chapter number 1, Rotational Dynamics, and it is kinetic energy of rolling body. So in previous class, we already learned kinetic energy of rotating body, and kinetic energy of rotating body we get 1 by 2 I omega square. So this is for rotating body. Now we have to find out if the body is rolling, then how much is the kinetic energy. Basically, for that we consider body of mass m, radius r. It is rolling on inclined plane with angle inclination theta and height h. Then you can see this body in a diagram. Initially, this body having a zero velocity. We release this body. So when this body is coming down, so this body is moving in a straight line motion. It means that this body having a translational kinetic energy, as well as it is coming down. So that time it is rotating also. It has a rotational kinetic energy also. So this rolling body having two kinetic energy. First one is translational kinetic energy, means straight line kinetic energy, and it is rotating also. So it has a rotational kinetic energy also. So we can write total kinetic energy is by this formula. Total kinetic energy is translational kinetic energy plus rotational kinetic energy. Now translational kinetic energy we already know, 1 by 2 mv square, mass into velocity square. And rotational kinetic energy we already derived, half I omega square. I is the moment of inertia and omega is the angular velocity. Now after that, we have to use here the relation between linear and angular velocity. We know that V is equal to R omega. So by using that, as well as we know the I is equal to mk square. So V is R omega. So I can write here omega is equal to V by R. Omega is V by R. Okay, you can see here omega is V by R. So omega square you get V square by R square you will get, because omega square we have to substitute in a equation, omega square and I. So this omega square and this I both we substitute in this equation. Then what we get? You can see here. So we get an equation for kinetic energy, half mv square plus half mk square. Mk square means this is I we substitute, and this V by R square bracket square basically, or we can write V square by R square by simplifying bracket also. Now after that, we can take a common. What is common in this? Half is common, m is common, v square is common in every term. Half mv square we are taken common. So as I take half mv square common, so in a bracket I get 1 plus k square by r square. And this is expression for rolling kinetic energy. You remember this, rolling kinetic energy and rotating kinetic energy is different. This question is already asked in the board exam, so very important, you have to prepare it very well. Now we are going for the next article. Same motion we have to study, rolling motion of body without slipping on an inclined plane. Again, we consider body of mass m, radius r, rolling on inclined plane with angle of inclination theta and height h. You can see a diagram. Now here initial velocity of this body is 0. So when initially the body is at its highest point or at height h, that time body having a potential energy, and it is equal to mgh. This is a potential energy. Kinetic energy is 0 because its initial speed is 0. As we release the body, then its potential energy start decreasing, because when it is reaching to this height, then height decreases, then potential energy decreases. Potential energy start decreasing. At the same time, kinetic energy start increasing. When body reaches to this bottom point, then potential energy is 0, because potential energy formula is mgh, and h is 0 that point. So here the body having kinetic energy, means whatever the potential energy body has, it is converted into kinetic energy. By conservation of energy basically, because here kinetic energy is 0. And here kinetic energy we can write half mv square and potential energy 0. So total energy at highest point and lowest point is same. Now after that, we can write for this type of motion here, this loss of potential energy. We can write loss of potential energy is equal to gain in kinetic energy. So how much potential energy is lost? mgh. Means loss of potential energy means this potential energy minus this one. So mgh. So here gain in kinetic energy. Now basically you can see here, so this body is rolling. This body is rolling. So here at the bottom body having a kinetic energy. So I written only mv square here. Kinetic energy is half mv square 1 plus k square by r square. So here, okay, this is the kinetic energy. Means here this loss of potential energy is equal to gain in kinetic energy. We have written this kinetic energy because this body is the rolling body. And in the previous article, we already obtained kinetic energy of the rolling body. Now after that, we have to simplify this equation. We can cancel the common term. This m and this m we can cancel. Then 2 we can shift to this side. So here 2 is divided, to this side 2 is multiplied. 2gh is equal, and we can transfer this bracket also to this side, left hand side. So here bracket is multiplied to v square. So here it is divided. So we get formula of v square, 2gh divided by 1 plus k square by r square. Now we have to write formula for v. So velocity is given by this formula, under root 2gh divided by 1 plus k square by r square. Now this is expression for kinetic, this is expression for velocity of rolling body. Now after that, similar manner, we can find out acceleration also by using kinematical equation. This is accelerated motion. So by using kinematical equation, we have to find out. So as we already have idea, initial velocity is 0 here. So by using kinematical equation, v square is equal to u square plus 2as. So here this u is 0, so it get cancelled. By using that, we can write a is equal to v square by 2s. Now here v square, just we obtain v square in the previous page. So here v square we can write 2gh divided by 1 plus k square by r square. So v is under root everything, but v square is this. Now this v square we have to substitute in this equation. Then what we get? Then we get a is equal to this 1 upon 2s we are written, and then this is a v square. So this formula of a is v square by 2s. In that we substitute vs. So we get this. Now we can cancel here whatever the common term. This 2 you want to cancel, then you can cancel this 2 also. And we have to substitute here. So you can see a diagram here. So this is a diagram. So this is theta. This is height h, and this distance is s. So sine theta is what? Opposite side h divided by hypotenuse s. Sine theta we get h by s. So s is equal to h by sine theta. Or we can write here h is equal to s into sine theta. You can substitute anything here. Now we substitute. I consider here s, so I substituted this s. So s is h upon sine theta. Okay. Then after that we have to cancel the common term. We cancel here. You can see we cancel this 2, 2. Then this sine theta, this h get cancelled. Sine theta is shifted up. This g and sine theta, we get g sine theta. Divided by this bracket 1 plus k square by r square as it is. So this is expression for acceleration. So this is a rolling acceleration that you note. And this is very important article. In board examination, in previous board examination, question is already asked about this derivation, as well as they may ask rolling acceleration of a particular object also. So only the thing is you have to substitute k square by r square for that object, and then you will get the acceleration.